there was nothing solid to hold on to in reality. The fundamental question in modern philosophy that has really just been a stumper and has led to this whole postmodern turn where people don't think there's no objective basis for any reality is the question of the reliability of the human mind. On what basis can we trust the way our minds process all that sensory information? This goes back to Hume and Kant and some of the philosophers in the Enlightenment period. And from that point forward, there was a great doubt. Maybe we can't trust our minds. Maybe we can't trust. We have all these things we assume about reality in order to make sense about reality. Every cause has an effect, for example. But we can't prove those things. We have to use those assumptions in order to know anything at all. If we try to justify our ability to know the world around us by empirical data, by things we observe, this was Hume's argument. Can't do it. He was a radical empiricist and found that in order to make any sense of the sense impressions he had to presuppose the uniformity of nature. But to prove the uniformity of nature, he had to make reference to sensory observations, and so he was arguing in a circle. And so it came down, you couldn't justify the reliability of assumptions we make in our minds by observing the world. You had to use those assumptions to make sense of the observations. But if you presuppose that our minds were made by a benevolent creator who gave us those assumptions in order to make sense of the world that he also made, then there was a principle of correspondence between the way the mind worked and the way the world worked, in which case we could trust the basic reliability of the mind. And this turns out to be one of the key foundational assumptions that gave rise to modern science. It was called the idea of intelligibility. Newton, Boyle, Kepler, the great founders of modern science, thought that nature had secrets to reveal. There were patterns there to be revealed that we could understand because our minds had been made in the image of the same rational creator who had built rationality and design and pattern and lawful order into the world.
Do you believe in evolution?
I believe in, I believe in microevolution. I believe that there are real evolutionary processes. I'm skeptical about what's called universal common descent, the idea that all living forms have evolved from one single common ancestor. I'm profoundly skeptical about chemical evolution, the idea that the non-living chemicals in a prebiotic ocean or prebiotic soup arrange themselves to form the first living cell. And I'm also skeptical about the creative power of the mutation selection mechanism, which, as it happens, so are many leading evolutionary biologists today. I attended a conference in 2016 at convened by the Royal Society in London, Royal Society being the oldest and most august scientific body in the world. And it was convened by a group of evolutionary biologists who were essentially dissatisfied with neo-Darwinism, the standard textbook theory that we learn in all high school and college textbooks. And many of them were saying we need a new theory of evolution. The first talk at that conference was given by Gerd Müller, a prominent Austrian evolutionary biologist, and he simply enumerated the 5 major what he called explanatory deficits of neo-Darwinism. And his basic perspective was the mutation selection mechanism does a good job of optimizing or modifying pre-existing forms. It can generate small-scale variation, but it does a very poor job of explaining the origin of those forms. Think about, for example, Darwin's finch beaks. Great job of explaining how variations in weather patterns result in changes in the shape and structure of the finch beaks. But that mechanism turns out not to do a good job of explaining the origin of birds or other major animal groups in the first place. So modification, yes. Innovation, no.
But modification over massive amounts of time, don't you think that would eventually lead to new groups? Because a lot of new groups have similar origins, or at least origins from one ancestor.
Well, time,
like primates.
Yeah, time was always the hero of the plot. But let me just run a couple of arguments by it, and let's see what you think. Okay, and I developed these in a lot of detail in my book Darwin's Doubt. If we now know, thanks to the genetic revolution, the molecular biological revolution, that if you want to build a new form of life, you have to have new code, because all new forms of life depend upon new anatomical, a fundamentally new type of animal, for example. So you need new anatomical structures but the new anatomical structures require new cell types, new types. So if you got animals that first come on the line and they have a digestive system, they have a gut. Well, you got to have enzymes that can service a gut, that can process food. So enzymes are types of proteins. Proteins are built from the informational code in DNA. So anytime you want to get it's just like in the computer world. If you want to give your computer a new function, you've got to provide new code. So we have these long digital bit strings, A's, C's, G's, and T's, not zeros and ones, but A's, C's, G's, and T's in a digital string, and we call that a gene. And if you have a section of DNA for building a protein, that's great, all works. Now, but if you want to build a fundamentally new form of life, you got to have new proteins to service the new cell types to build the new anatomical structures. In our computer world, we know that if you start randomly changing the zeros and ones in a section of digital code, you're going to degrade the function of that code long before you come up with a new string for making a new program or operating system. The functional sequences they're highly isolated in what's called sequence space. You can change a few things and still retain function, but after a very few number of changes, you're going to degrade the function, and long before you come up with a new function. Now, the Darwinian mechanism starts with the idea that there are random changes in those digital bit strings, those sequences of A's, C's, G's, and T's. And based on our experience in the computer world, we would expect that random changes are going to, again, degrade those strings long before they're capable of building a new protein.